Hello, everybody, and welcome to Rocket Lasso Live, episode 8 today of season 4. How is everyone doing? It looks like the streaming setup did work for YouTube today, which is good. It's a little bit more manual, but it's going to seem to work, although the subscriber stuff didn't seem to be working, but whatever. Hi, everybody on Twitch. Hi, everybody on YouTube. Welcome, Joel. Welcome, Alberto. Both people saying it's first-time chats. Roger, Marco, how's it going? Tobias, Trey, Mick, Bosnian, Sean, hi everybody. Animation Hamster, Real, more people popping in every second. How's it going, everybody? Let's start getting those questions together. I don't have too much to cover beforehand. If you're on YouTube, type out a question. If you want to put a link, jump over to Twitch instead. So twitch.com/rocketlasso, I think. You can put links over there, although I will jump back and forth between it. If you're putting a link, I need to see the artist or studio who created it, but I do like typed out questions, so don't worry about that either. Pierre, Michael, Scott, how's it going, everybody? And it's not Michael Scott, it's Scott and Michael. Elaine, welcome. Bralius, of course. Hello. Happy Wednesday, everybody. So start getting those questions together. The only little thing that I did, and I guess it's not out yet, and everybody who's here in the live stream is going to be well aware of it already. Do I have it up and handy? Yes. So I clipped out the section from last week's live stream where we did the question of can you clone fields, and when I was editing it to upload, I noticed that this was like a really good segment that kind of makes for a good standalone tutorial without me having to even re-record anything. So I did a little bit of editing and put that out there. So yeah, excellent question. It was really fun to answer, and it kind of opened up some opportunities. I mean, it's things that I had thought about, but not like as a proper system. So yeah, I uploaded that. It is available for anybody supporting on Patreon, and then probably like Monday I'll put it out for everybody to be able to watch. So just throwing that out there. In any case, let's check the chat and see how everybody's doing. Crossfader coming in immediately with the rubber band question. I remember that there was a question you were going to hit me up with. Trey, everybody on YouTube, start getting some questions together if you want as well. But let's try and tackle Crossfader's question. So the basic idea is your standard rubber band. Let me see if I can Google the equivalent one. Rubber band airplane. Images, please. And let's pull it over here. So yeah, this is, at least I remember having a couple of these when I was a kid. This one, that's a video. So you can see what ends up happening is you got this propeller and you've got this big thick rubber band that runs along it to a static point on the plane, and you can take the propeller and just spin it and spin and spin it. Of course, the rubber band's going to spin it back the other direction. So the question essentially was, can we do that? And I mean, it goes to, there's a big difference between a rubber band powered toy and faking it. And I don't think that we're going to get enough tension and kind of dynamics out of doing it for real, because there's not going to be that stored energy in a really big way. Because just think of when you spin the rubber band, like how much stretch is happening. Having said that, like, why don't we, as a, kind of just a counterpoint, why don't we see how far we can push it, and then we'll probably build the fake version of it. So what's going to be the best way? I don't want to use utility splines yet, but I do want a very even count going around. Let's just see what we can do. So maybe I'm overthinking it. Let's round that and make it really thin on one side and sweep it. Well, do we want to run it on the spline, or do we want to run it on the geometry? Very different prospects. Very different prospects indeed. Either way, we'll see the visual of the rubber band. So let me create the sweep, and that will get another rectangle. That one gets no rounding, set to 1 by 1 for now. Give it some thickness. Okay, so let's call this our basic rubber band. Yeah, something like that. Let's check out our subdivisions and B, and you can see that we get all this rounding in the corner, but none in the middle, which is obviously something we'd like to avoid. So change this from adaptive to subdivided, hopefully. Angle will be 90, and that's still not doing a great job of subdividing for us, I gotta say. You can see how I feel like there might be a small bug in the intermediate points inside of Cinema, because this is still behaving as if this is like a uniform distribution or one of these other types, because you see these are getting pinched in the corners. So we could say uniform, and that will do a okay job of getting it uniformly across. It's not a very intuitive way of doing it, because like, it says 28, but there is no 28 here. I think it's actually subdividing like 28 times on average between each point. It's a very unintuitive way of doing it, but at least we get a nice even count in this particular instance. It would be a good reason to use the upcoming utility splines, but we're not quite there yet. So yeah, we're leaving it super basic here. Let's put a cylinder, and having a decent number of subdivisions is not a bad thing. It's supposed to be in the system, and we're going to attempt to do this with the cloth and the rope to start with. So we'll make that one just a collider. I guess they'll both be colliders. But then this one we will make spin. And I suppose we'll just do it manually. And I think it'll get stuck on there pretty well. So Control D, I'll turn off gravity under simulation and turn on CPU. So no gravity, and I'm on CPU. These two shapes will become simulation colliders. And I'm going to start with the spline. Actually, no, let's start with the object. I don't expect this to work terribly well. And I don't know about these subdivisions and the thickness. There's a lot of variables that could make this bad. The one thing I do know is I think we're going to want a bunch of friction, just so this doesn't slide off. So I'll crank the friction up a bit. And we're in this kind of larger scale, so I think all the defaults will work just fine. So this is going to be cylinder.spin, just so I know which one is which. Coordinates, and we want to spin on the P. So we're going to spin on that one, record at the beginning, and let's go up to frame 900. And let's go overboard. So we'll do 7200. We'll do that to start out with. Might not be high enough. Did I do the thing I always do? No, it's correct. Okay, so let's save it right away just in case. And put it in scene files. If you are supporting on Patreon, you get access to these scene files. Twist rubber band. Okay, so now let's hit play, and okay, I mean, you see it, the super basics are working. Now, as it does spin, it's doing a fine job of it. You see that this is starting to twist up. Now, if we keep on going, it's doing an okay job, but immediately you can see these are starting to intersect with each other. So it's doing okay to begin with. I would like to drain some more energy out from it. We can't make it taut. Unfortunately, right now, there's nothing like the rest setting. A good idea, maybe we take this spin and we also animate it to move further out so it will put some tension in there. So I will keyframe that, and over the first, let's say 60-ish frames, we will have that move about there, not too far. So we'll do that to begin with, just to let that be a little more taut. And already you can see, yeah, it's staying a little bit more a straight line. Getting a little less wiggle, and it's twisting better because there's some tension on it. But after we get a couple of twists, I imagine it's going to start sneaking through itself, where you see it's getting really tight here, doesn't know quite what to do with it, and then it's going to, like you see right there, it's passing right through. So already we're hitting the limitation when it comes to that specifically. A couple things we might do. Let's subdivide this at least one more time. I'll set that to uniform, and uniform, please, and put that to 1. Yes, you see, uniform is very strange. It doesn't evenly distribute things. So let's try natural. Yeah, natural is what I wanted. So I just wanted an extra subdivision there. Let's do another one. Actually, that does put extra ones here on the side as well. So, we could make that editable. But let's see what this does. We get a couple extra points and polygons, but more detail should make it so it's harder for them to pass through each other. You can already see, like, that's, we've created like way more than double the points that there used to be, so it's going significantly slower. Spinning, doing fine so far. I haven't seen any sneak through yet. Seems okay. There's a lot of kind of, oh, there, they suddenly snuck through each other. So this is all with the default settings, and it's kind of what I was expecting. Now, we can, I'm going to pull back on this a little bit. We can start changing some settings here to try and get some more control over it. And things will start getting slower. But the first thing we should do is probably more collision passes. I'll jump that up to 10, so there's 5 times as many. And that will be the only thing we change. But that is going to probably give us a significant amount of slowdown. Actually, that's super... That was like not even going forward a frame. Hang on. The Cinema did not like just jumping those collision passes up. I wonder if that froze itself up. Everything else seems fine. So, everything else seems fine. Cinema itself is a little bit stuck. We'll give that a second to see if it wakes up. Otherwise, I will kill it off. I'm preparing by opening up the task manager. The yeah, 10 collision passes is not much. I can't think of why that would have crashed. It just seems kind of like a fluke. It's not waking up, so I don't want it to go too far. And we did save, so we didn't lose too much. So I'll kill it off. But yeah, that's no good. I don't see any reason why that should have crashed, especially on the CPU. If that was on the GPU, I'd maybe understand, because I'm having all those weird CPU problems. Okay, Cinema opened again, nice and quick. Let's open it again. Because we crashed it, lost it, so let me open it manually. I think we probably lost our keyframes. Okay, well, we just lost the stretching keyframe, so keyframe that. Show them forward 60. Give it some tension. Rewind, save, Control D. Back to our simulation. Everything is default. We're on CPU. Let's try, I'm going to sneak up on it. Let's do 4 and hit play. And you see that started right away. I don't know why the other one, there's no reason why it should have done that. So anyway, I don't think 4 is going to be too much higher. I'm just trying to creep up on it. But anyway, I'm going to jump back up to 10. Yeah, that started right away this time. I know that we got slightly different poly count, but still, like there was no reason for that to have happened there. So, we didn't change much. There's no more sub-steps, so it's not any more accurate that way. But as far as these sneaking through each other collision-wise, I would think that this would be potentially significantly better. Although, yeah, they're already starting to pass through. Essentially, these are the limitations I was expecting. I don't know how far we can push this. Let's go up to 30. And there's the polish iterations. I do not mechanically know what that means. I just know that adding more collision passes is supposed to help. If you're adding collision passes, it typically is going to be nice to add a polish iteration. Those kind of go hand in hand. Still running slower. Although, you know what, we're running this with thickness already. I don't think we need thickness. We could probably have the entire thing speed up if these weren't of volume. So let's make that tweak right after we see how this goes. I just want to see, I mean, because this should be more than 3 times better than what we saw before, but what does that even translate to? I mean, those twisted up nicely, but they didn't seem to pass through each other, so that's an improvement. The, yeah, it doesn't, something about the overall thing doesn't seem terribly happy, though. And there's a lot of energy just kind of flying through the scene, so I think we want to slow all that down a bit. So I will create a friction, and you need really high friction for this to start doing anything. I'm going to add 3, actually, let's add 4 zeros and go up to 10,000 just to see if I can see a visual difference. Yeah, okay, that definitely is draining a lot of the energy out because the rubber bands aren't going to have like all that. It's not going to be behaving like a piece of string. It's going to be stretched taut. But you see this friction is really draining the energy out, maybe too much. So I'll drop that down. And yeah, you can see how everything would calm down now. But anyway, we can increase the speed and a bunch of things. If we just pull out that rectangle and we'll put a end side instead. Set the end side to 2 and make that length 10. Get the correct orientation, which isn't any of these. And when you end up with this kind of like none of those orientations are correct, what I typically do to keep it parametric is throw into a connect and then rotate the child on whatever the correct axis is, in which case, there we go, it was on that one. Spin it 90, so now you can see that it's still being treated as a spline, but the axis has been rotated for us. Okay, so now, nothing should change except that there's no what am I trying to say? There's no thickness to it. Okay, I'll give that a save. These we're a little bit more rectangular, which does mean it's going to run slower, but I think it's going to be better overall. So you can see the friction is stopping it from going super crazy, and the extra polygons might help with them not intersecting through each other as much, but you never know. So let's just see what this does. Yeah, you can see it's a lot calmer. Well, it might lose it, but let's hope that this carries through. Getting tight here. I think the friction especially is stopping from going too far. We might be able to pull back on the friction, but that's okay. It's definitely behaving better. I think the extra subdivisions, I think it not having thickness there, it finally failed, I think. I mean, keep in mind, like the actual rubber bands will do these secondary twists. So actually maybe that didn't fail. It doesn't look wrong yet. Is spinning a rubber band, I feel like that's pretty similar to what we would really get. So it is better than it's better than I thought it would be. But here's a couple, well, here's the problem is like the idea of running this as a rubber band, that's actually working really well. Like it's getting really pinched here, but the way this is like these two different types of twists is the way a rubber band will twist up. So yeah, color me decently impressed here with the settings that we have right now. The problem is that there's nothing like a connector, like under simulation, under the bullet dynamics, we got all those different connector types, which means we could then use this to drive something forward. But this doesn't work that way. So these systems can't go back and forth. So I just want to see how well we could twist it up here, and it's working surprisingly well. And honestly, I was going to say we could try it with a rope, but with a rope, it's going to be kind of one-dimensional, which could work if you know how you can have like rubber bands that have a square profile. Like we could do that. So, you know, let's do that. We'll save this one as that one working. I'll save the next version as twist rubber band rope. And let's just rename this one to cloth while I'm thinking about it. Stay organized. Rope. Okay, so if this was the case, we would delete the cloth, and honestly, let's turn this. No, we don't need to turn off the sweep, but what we do need to do is feed it I'll just make a new rectangle because it's going to have better settings for us. Feed a new rectangle, and it needs to be real small. Let's say 2, 2. Yeah, so you get these square types, which typically I think is the type you put in that rubber band plane more anyway, at least from what I remember. And this is what we put the rope on. Nothing else should need to change. I'll put a bunch of friction on there. There's always a chance it slides off, but now this is just based on the spline. So let's just see. I'll hit save again. Let's see what this gives us. So once again, pulling it taut. Let's start spinning. Oh yeah, we're gonna need some thickness there. And currently this is set to 2 by 2. So, and that's a radius. So I'll try setting that to 4. Okay, yeah, 4 seems really good. So you can see this twisting around. The friction might be stopping these from traveling too far back. So I'm going to pull back quite a bit on friction. As soon as I do, you see how it starts like wobbling all over the place. So maybe it doesn't travel as far back as I thought it would. So I'm going to leave that friction up so it doesn't go too crazy. And you can see this twisting up. Now everything's going to be running quicker on the spline. There's just less going on. And it's doing a pretty good job here. I haven't seen anything like escape through, but it's, like I say, it's not doing a great job of translating all of this up through it. Of course, maybe that, I don't think so. I was going to say maybe the high friction is stopping that from sliding through, and maybe it is. I don't know. So let me try putting the friction way down. So let's do like 0.1 on the friction. I think it's kind of stuck in the middle here, so maybe that still works. And let's just see if that is able to travel and propagate back through with less friction. And at a glance, it does seem to be. Do you see these seem to be able to slide back until they're kind of getting into a more even position? So, you always got to think of those variables. Yeah, look how much better they're getting evenly distributed. And that's just changing friction. So that kind of thing is pretty cool to find that out. We definitely need to set something up to get the orientation to not be twisting around, which is easier said than done. But that's doing a good job of twisting around. It hasn't failed anywhere. It's twitching, but nothing's passed through each other. But we need to twist this around like 10 times as many times. But again, we're going to be left with that same problem of like, we can't back drive this. We can't now feed this through a system and say like, oh, there's a bunch of tension built up. Although what I would be curious at would be, I'm going to add a whole bunch more frames there, and I'm just going to turn off the spinning one, and I want to see how well this untwists and just kind of what it looks like. Keep in mind there's a lot of friction here still. So it's going to be like really calming it down. But yeah, immediately you see it is untwisting itself. Like it does, there is tension as far as the twisting, but I would imagine that the energy is going to drain out pretty quick. We could turn off the friction, which I now have done. Keep in mind there's no gravity. And it's going to, you know, presumably it would untwist all the way because that's its natural state. There's no gravity, so there's no additional forces. But you see, there's not much power behind this. So even if we did have the ability to do things like connectors, I don't think that this would actually be storing much in the way of energy. I mean, if we twisted it 10 times more, it would spin back 10 times as much. But you do start hitting the practical limits. So it's just something to keep in mind. I'm trying to think of if I wanted to stop this from popping, because this is a pretty common problem for everybody, right? Where you don't want this to be popping and twisting as it goes, but it's not a trivial thing to stop it. I mean, if we put in, even that I think is too dangerous. Like we make a rail spline here. I could scoot this off to the side, tell the sweep to don't look at the scale. Right now it's just looking at the direction, so it's kind of saying like, oh, I want to face that way. But I honestly don't know how this is going to react when it starts twisting around. It looks very odd. Yeah, it's already getting quite confused. I mean, it's not twitching, but you see it's getting pinched in a weird spot, and we definitely need the friction. Calm down. Yeah, it's a tricky one. I wonder. This is just kind of academic because, like I said, I want to see if there was a way of stopping that. I wonder. This might be trickier than I thought it was. I was wondering if utility splines, which obviously isn't out yet, if it would be able to help here. I don't know if it would. It's kind of an experiment. So if I make a smooth spline, what I could do is say, hey, reference an object, and that object will be this rope. You know, so it's already rope. And now essentially what I'm curious about is, will the smooth spline see the rope? Will it be able to see its updated, deformed version? And actually, yeah, look, it's working perfectly as far as that. Now the idea is, because this is a smooth that is going to take everything and it's going to pinch it inward. So you should be able to see over here that, let me show you. If I turn off the sweep, the smoothing is saying like, oh, like pull, you know, it's averaging out the other points, so it kind of pulls inward. And see how that's kind of giving us a direction here? Now, unfortunately, that doesn't go all, it doesn't follow through the entire, I mean, it does go through the entire system, but that's not going to tug down in the middle. So honestly, I just don't know what this is going to do. We've got our, yeah, we're not using scale, we're only using direction. I think it's not going to look too great in the beginning. Yeah, because it pinches down there. But after it gets a few twists in there, I wonder if it would be able to start seeing it a little bit more properly. Again, it's not twitching, but it's not giving the effect that I really want. Because it's like you need to shrink it all in based on a particular normal direction, and that's not what smooth is designed to do. But it is giving us a consistent twist. Yeah, I was just curious. Anyway, all of that was kind of academic. It was just like, okay, what happens if we tried to do it through the simulation systems? So now that we know that, you know, obviously there are limitations when it comes to the simulation systems, what if we say, okay, well, we're not worried about the simulation. Let's just fake it. Like, let's get the visual of what that was doing. So let me set that to natural and just do a couple subdivisions, because we can get away with this being a little bit easier. I do want, how do I want to do this? A couple different things in my head. I think, yeah, if we're going to build this real meticulous like, I think I don't want that to have that kind of thickness. I want it to be, again, the end side. And that does, again, we'll need to go into a connect, become two-dimensional, be 10. And again, we have to rotate it on the proper axis, 90 degrees. Okay, pretty easy. Now we've got a two-dimensional version of that. And let's just do this with a bend deformer. But we need to do a couple of additional things. Like this is our spin right now, but that spin isn't really going to be doing what I want it to. So here's my thought. What if we set this to 1 by 1, give it a orientation along the rubber band. I'm going to move this over here to the end, right where essentially that spinning part would be. And I'm doing that because the hope is I can make a null. The hope is I can deform that plane to be deformed in the exact same way that the rubber band is. And then we can use that position to drive our, the stick, essentially this stick. So let's keep it simple. Bend, or not bend, a twist. So we'll make a twist. I want the twist. Which orientation do we want? Do we want it left or right? I don't know. Drop it here. Actually, let's make it a child of the sweep, because then I should be able to say aim along X plus and fit to parent. Is that correct? Seems to be. Yes, excellent. Okay, yeah, okay, I got it right on the first try. Okay, turn that off, move it just into this null in general, which means it should apply to the plane and the sweep. And now when I twist this, you should see that we do get that polygon, and that polygon is spinning around, so that's a good thing. Now, I guess these sticks, I mean, in theory, these sticks should be a lot thinner, but let's just experiment with where we're at here. So how far can we twist this? Let's keyframe that, and then it's kind of a little bit more manual right now, but let's let it spin for a while. So let's crank this up, and how far can we go until just visually this breaks? Now, I guess, yeah, we got some problems because we want that to actually pinch in and get really tight as well. We can do that though. Let's do that. How do I want to do that? We've got options. Bulge is an obvious one, but Bulge's curvature isn't as good as I want. I don't think it's going to be as good as I want it to be. Fit to parent. And if we were to do a bunch of strength here and pull down, you can see it's going to pinch it in. But that's, first of all, it's pinching it in 3-dimensionally, and I only want it to be 2-dimensionally. I wonder if we can get away with tricking it and scaling the object. No. It's just a shot in the dark anyway. Yeah, it's not a variable. But yeah, you see it pinches in everywhere. And not only that, I mean, yes, we can affect this curve. Well, I guess we can go beyond 100, but then it starts like inverting, and we don't want that. So yeah, bulge, the simple way doesn't work. Honestly, FFD feels like what I want, but FFD isn't super easy to keyframe. We could try a morph tag on it. That might be for the best, honestly. FFD. There it is. Okay, so does this have, yeah, this one, oh, it does have a fit to parent, but this one is rectangular, so we just do that. So we've now fit to the parent. I don't care about Y, I don't think. We don't care about Z. In this particular orientation, I care mostly about X. So we need enough subdivisions on X so that we get near the edges. So I'm going to go pretty high, like 20. Yeah, that gives us a decent amount of fidelity. I don't know. Let me save this. So there's going to be C, and it's going to be twist. Okay. I can't remember if the FFD works with the morph tag. It'd be unfortunate if it didn't. So pose morph, and it will be manipulating the points. That's just fine. So it's got its base pose. It should already know that. And now I should be able to select all the points, deselect. Why is it not? I'm holding on control as I select, and it's, what is going on here? Point mode. What's going on here? FFD. Why? What is happening right now? Copy, new, paste. Point mode. They're all selected already. Wait, now it let me deselect them. Okay, it worked there. Let's go back to this file. So I'm holding on control, and it did let me erase. What? That just seemed odd. I'm gonna select all again. Oh no, now it is letting me erase. Wow, I have no idea what happened there. But anyway, I just wanted to, actually, let's deselect everything but the outermost two. And we are in the morph tag, and we are affecting pose as 0. So hopefully I can hit T and start scaling this down. Essentially, this is all I wanted to do, is get that really flat. And potentially we could stretch outward, and maybe we even needed some more subdivision. You can see essentially what I was going for. So now, can we put that in animate, and can I morph? Yes, excellent. Okay, so give that some credit there. We could keyframe them separately. We could also use like Espresso or something and have one drive the other. But in any case, and actually this one can just stay inside the sweep because I don't want it pinching down the plane. So we could now do this morph as it's twisting. So let's say at the time of 0, it looks at 0%, and I think we're doing all the way up to 800. So now let's say that that's starting to twist up. So we start going really far. This should calculate before that one because it's deeper in the hierarchy. So if, let's say this was really far up like that, as we pinch this in, yeah, that starts looking better already, where those start getting really close to each other. And, you know, I'm just gonna go up to 100% because I think we set it up pretty well for that. So you can see it's twisted up pretty well. And as it's twisting, that's gonna get tighter. Now we can keep on going. You can see our entire rig is gonna start kind of breaking down a little bit. So let's arbitrarily put this at 10,000. And we clearly don't have enough subdivisions here. So let's double them, and you can see I get a bunch more. Still not enough. Let's go up to 100. And now you see, okay, we do have enough for it to actually be maintaining this curvature. I do feel like it'd be good if this end side had a subdivision. So let's set that to natural. And yeah, a couple subdivisions on there. And because we're just deforming, like we don't need to go like, we don't have to, it doesn't have to be super duper low poly. We have, you know, this will run relatively quickly even still. I'll subdivide that some more. So you can definitely see these starting to twist more. Now, they are pinching, but like I'm starting to think that even after they pinch, that maybe we'd want them to scale down more. Maybe. So like the thought would be like put another one of this FFD. Of course, it's not catching all the points, unfortunately, but that was easy to set up. So if we delete, I don't want to delete the morph tag, but I will edit, delete, and then we got back to the base pose. So if we need to make it larger, I think I'm going to go overboard, so it's going to miss by quite a bit. So let's make it a little bit deeper, even though I don't think those are affected too much. And that's currently 17 by 20. I'll set it to 50 by 50. So you see it's way overshooting the overall shape. But that doesn't stop us from adding a new pose and scaling those down to pretty much 0. And yeah, pretty much the same thing. So go back to animate. And now we have an FFD. Let's go over to our lovely frame 800. And yeah, here's what it looks like right now. So our second FFD can start squishing it down, but that is so not what I wanted it to be. Yeah, that makes sense. I guess what I actually want to do is when it's getting pinched in towards the middle, they should actually be getting thinner. Yeah. Let's see what that looks like. Oh, anyway, you'll see as I start twisting this, I guess these would kind of pinch in almost immediately. So as soon as this twists, I guess maybe this morph should be happening very quickly. So I'm going to, oops, let's go back to pretty near the beginning. So like right around there, I'd almost expect them to be like already bumping into each other. So if I can carefully grab this keyframe and start pulling back, you can see these should start stretching in to like start laying on top of each other. So maybe that just happens really quickly. Let's see. Yeah, that was pretty seamless. And then it would just keep on spinning. Yeah, that makes sense. So then it goes to, as it keeps on spinning around, in theory, these should be like shrinking in a little bit because they're getting stretched more. I don't have a good, I don't have an immediate thing popping in my head for the perfect way of doing that. Also, you see this beginning is getting twisted up, but we can fix that just by grabbing the twist and like pulling it a little bit further out. We'd probably want a nicer transition there, but I'm not going to worry about it. Yeah, anyway, you can see how we're building a rig to manually keyframe this going. And as I had said, keep in mind that we could always modify. We can have one part of the rig driving the other one, so you don't ever have to keyframe one thing. And then even as these pinch in, I don't know, it is fundamentally different. Like, you get nice twists and all, but it does feel fundamentally different from the dynamic one where we're getting those nice secondary twists and everything. So maybe you could still leave those. I don't know. It's tricky. Anyway, let's throw this into our old friend, the cloth surface. Don't subdivide, but yes, let's get a little bit of thickness going. Apparently it wants a negative thick. Oh, no, they're aligned? Really? Well, the angles are strange. I guess it is working, but strangely. Very twisted. I don't like what the cloth is doing there, so as an alternative, I'm going to put it into a null and grab a node geometry modifier, and it's called solidify. So if I put in a solidify, it looks like it's very similar. Maybe a little better. But you see it's kind of getting twisted as well. But anyway, I was just trying to give the rubber bands a little bit of thickness. So, yeah, if we look at it with that, I guess it gives it some okay thickness. Yeah, I mean, especially this first part looks really good as it's twisting. But at a certain point, I feel like in a normal rubber band, when you get to around this point, it suddenly would twist. It would do that double twist on top of itself. And I just don't think that this setup is capable of that. Especially, like, I mean, out of morbid curiosity, I'm going to create a second twist. And let's kill the keyframes, manually put in a twist. Yeah, see, this doesn't, yeah, that's not doing at all what I want it to. Yeah, it seems to have almost no effect. It's just twisting more. One of the thoughts was going to be if we could start isolating that to a particular spot and have it like double up. You know, potentially if I rotate it, we'll get some funky, you know, get some crazy twisty things. But yeah, not really what I want. So it does go back to, if you wanted to do it for real, you'd have to do it with the simulation stuff with some crazy high cranked up numbers. Pretty tricky. Dean is asking, what does the solidify geometry node do? It essentially just does an extrusion. Its thickness, it's like an extrude with a cap for all purposes. Essentially, it's just like the cloth NURBS. But, yeah. I mean, it's making me want the cloth, but the cloth isn't going to be, it's not going to, I guess you can increase the sub steps and make it snappier, but it is making me wonder if we could just have those two systems play really well with each other. Like, that could be a thing. I don't know. We're spending a lot of time on this one, and I'm not, well, I'll just say I'm not in love with some of the directions we're going with it. Because at this point, it's like, okay, well, now we're starting to fake it. We were already faking it, but now if we jump back to the twisted rubber band setup we had, and I renamed it, so we have to manually open it. If we go back to this one, which was doing like a really nice job of twisting, but you know our FPS is going to be tanking. Oh, and we should also keep in mind that the low friction had made it look nicer, where these could slide past each other. But anyway, yeah, this is going to be doing a pretty good job of getting the twist and getting the double twist going, and you know potentially we want to put more subdivisions in here, so we could do that and just have this be a secondary thing that runs. And in this case, I could temporarily turn it off, and we just like ignore that, and then, you know, make the propeller. But it just goes to building a rig that's driving, making a plane that flies via propeller is completely unrelated from doing this rubber band. We already have proved that one system cannot be dynamically driving the other. One system could be, we could make a motor, and the motor could be driving this as a dynamic object, and then we might be able to treat that as a cloth collider. Maybe, I don't know. But if we do that, they've got nothing to do with each other. One is just reacting to the other in a very linear way. And then it just starts turning into like, oh, we're just making like a flight sim with a plane, and the balancing and the calibrating and getting everything with the proper drag to balance out is, I don't know. I don't want to go too far with that one. It gets very, it's just very tedious. Like even when you look at this balsa plane, there's always a little bit of stuff where it's like you're trying to like bend something a particular direction so it's leaning in the right way. And you need to get the weight all balanced out and the propeller spinning the correct direction. The, you know, even going way back in the day, if I open up a file, you know, if you want to make the most basic of like propeller type things, let's just make a simple flying sphere for fun. See how quickly we can do this. Let's see. Honestly, these don't even need to be mechanically connected. So let's keep it low poly. That will get a, let's put it into a cloner. Stretch out on Z. Not too tall there. Create a twist. Twist. I super duper wish these were in alphabetical order. There it is. I swear it was up here before. Okay, anyway, that goes into here. That will be on Z+. It will fit to parent. That gets fed into a cloner. The cloner is set to radial of count of 2. Increase said radius like that. I'll shrink these in. I guess I'll have to keep changing the radius. But let's get a little bit of twist on there. Not too much. See, just a bit. A couple subdivisions on Z. Nice. And change the radius again. So you can see it just got some little propellers on there. Dynamically speaking, this would be connected. And we'd add a bullet rigid body. This also would get a bullet rigid body. But then these need to get connected. We could put them in the same compound shape. But I think we just, I would prefer a fixed connector right now. So let's do a connector, move it on up, and say, I just visually put them between, fixed connection between kind of this, the main like shaft coming up from it, and then the actual propellers. So those should now be dynamically linked together. This sphere also is a rigid body. And now we need another connector, which will connect from, I'm going to rearrange these slightly. So it's like propellers connect to the shaft, connect to the sphere. And this connector will connect from the shaft to the body of the sphere. And it is not a fixed connection. It is a hinge connection, right? But said hinge connection needs to be in the proper orientation. Now, even though they're not touching, and I mean, trivial to make them touch, I'll just scoot this down, just make them kind of visually a little bit closer. So, you know, that should be all good. If we apply this, things should just fall down. Now, actually, let's see, make sure they don't explode from each other. They do explode from each other. Now, let's figure out why. This connect should be welding everything down as a child. And the fixed connector, don't apply to children. It'll be a compound collision shape. Okay, that was the only problem. This was filtering down, and so I think it's like, it was almost like dynamically speaking, it was seeing a copy of the children. So now I'm telling it to only view the upper level. So now you can see it just drops, which is fine. But what's cool is on the rotor, I should be able to turn on some drag and some lift. And we don't need two-sided because these are volumes already. So let's just go crazy, and I'll say 100% and easy on the drag. So if I play with any luck, you can see as this falls, do you see how it naturally started spinning? So, you know, that's kind of cool. So if that is going to naturally, if that while falling down naturally spins backwards, well, let's make it want to spin the other direction. So simulate bullets motor. spin it in the correct direction. Just eyeball it to the center point. I don't even think that's necessary. Put it to where it's connecting between. That again will go from the shaft to, we'll just call this one the body. And motor will connect from one to the other. And it does apply, it should apply the force to both, but we could say, hey, just apply upward. And it's applying an angular speed right now. So if I play, we're not going to see too much. And you can see it seems to be spinning the opposite direction than we want it to. So I will change the direction. And let's just see if that looks any different. Maybe. Actually, well, yeah, because it's spinning in the same direction, maybe. Now, torque is going to be really important. So we're going to crank up the torque, which means there's way more power. You can see the sphere start spinning right away. Now, this is where this can work, but right now it's applying force to both. But I'm going to say, actually, just apply your force to A. So essentially, it's applying to the propeller, and it's not going to apply to the body, which is kind of breaking physics a little bit, but it's going to help us with our situation here. So let's keep on cranking up our torque. Okay, so now you see when I made the torque 10 times higher that it is spinning the correct direction. So I'm going to make it 10 times higher again. And now you can see that there's actually a little bit of weight to it. And you see how it looks like it's falling a little bit slower? Well, there's a lot of power behind this motor. Let's try doubling the speed of it. And now, as soon as the speed doubles, you can see that it actually wants to go upward. So essentially, we are creating lift now. This is actually lifting. So that's pretty cool. Let's increase our frames, and you can see that we actually get some sort of lift here. It's the most straightforward rig we could possibly do to actually make this do something. We can... I'm not sure what suddenly triggered it. Now, we would want to, actually there's probably slightly off kilter everywhere. So as soon as it tilts a little bit, yeah, it's going to suddenly like super flip out. Not surprising. And this could be, I don't think it's the axis. The fact that this isn't moving, I don't think is a variable, but I will move these connectors into the body. And then this can go into the shaft. So at least it moves with the object. But I don't think that's going to change anything. It'll still flip out and fall, and the placement of those didn't mean anything. And this is just because the center of mass is actually, it does seem to have changed a little bit. So maybe that was a variable. I guess what I'm trying to say is I think that if we were to, and keep in mind gravity is still turned on right now, but what I was trying to say is I think if we like drop something on this and it kind of adds in some like perturbations, if we knock it to the side, then I don't know how well it's going to be able to, it's not going to correct itself very well. You see how it's kind of spinning out of control? So there are things we could do to mitigate that. First of all, if we just make the sphere be way lower, then essentially we've pulled the center of mass further down. And I think that will naturally kind of like counterweigh it and pull it down a little bit more. And I think it'll be a little bit more balanced. And I don't know, it's hard to judge. I feel like it is recovered okay from that, but it's hard to judge. And then we can also fake that by changing its center of mass. So I'm just throwing out a couple variables here. But you can see here, all I'm trying to do is get it to lift, and there's already like a lot of variables. So the idea of taking this and putting it sideways and having it travel like horizontally and get lift gets more complicated. I mean, we can keep on stepping through a couple of the processes. Let's make it a little bit more visually interesting by, let's make it spin twice as fast. Let's see if we have enough power to do that. Put more torque and 3 times faster. Okay, so now we're starting to get a little bit of power there. You can see it's actually spinning. Zoop, zoop, zoop. Oh, yeah, and then just to throw it out there for anybody who's interested, if we, I haven't saved this one, so we might as well do it. I guess we're still on the same project. Bullet helicopter simple. Okay, just to throw it out there, if I make this null and I make everything a child of it, we can make a cloner, drop it inside, and spread these out a bit and get a whole collection of them. And these each will independently fly. Like it looks like they're all just identical clones of each other, but they're not. They are actually dynamic. Let's bring back in, I swear there's a bug in Cinema that is making it so that like 20% of the time it's automatically creating things as a child, and it was happening with my previous keyboard and the new one, so it's not like a sticky key. Bullets, rigid body. So you'll see if I let this drop and hit just one of them, that only that one was perturbed, and the rest of them are carrying on the exact same way. Or even simpler, let's just make 2 of these, and I'll say that some of them will want to spin slower and will blend. Hopefully that's not too slow. And yeah, see, they're all flying at different speeds now. Whee! So yeah, they're all independently dynamic, which is pretty cool. You can drop these kind of big dynamic systems into a cloner and the whole thing runs, which is a difference with the new simulation stuff, which could have its own advantages, but I think I'm going to end up missing our ability to drop something like this into a cloner. Anyway, let's go back to what I was originally saying, and that is, let's take this to the next step and try and act like this is actually an airplane. So let's put it off to the side now, and let's see. I guess we'll just do it with some cubes. So that will be the body. And essentially we just swap out the tag for there, this for that, and make sure that all the connectors are correctly updating to the body. Okay, so now, well, I think a similar thing should happen. This propeller is going to pull it forward, but presumably this back end is going to be really heavy, so eventually it's going to kind of twist down and kind of try and become the helicopter again. Or just, completely go out of control, which is also not necessarily surprising. So yeah, that's kind of doing its thing. So now, do I want to make this a compound collision shape? That might still work. So let's see, I'll duplicate this cube and we'll keep on adding components, and we will risk it by saying I want a compound collision shape, and we'll just let all these individual pieces stack up on each other as they will. So lay this flat, spin it. Simplest possible wings. Simplest possible tail. And reset PSR so that I can make a simple tail fin. Okay, that seems about as simple as we can possibly get. So this should be combining all those into one dynamic object. I don't know if it is, but it does have a whole bunch of drag applied to it, or maybe it doesn't. No, I didn't put any drag or lift on here, so that's actually important. Let's put 100% lift and again 10% drag and hit play. And now you can see that it is drifting slowly forward. The weight of it is still going to pull downward. So yeah, so you can actually see that that's kind of a variable. This is pulling through, and keep in mind again, gravity is turned on. Drag, I'm going to turn off drag on both of them because that might actually be slowing it down a bit. Yeah, you see, well, you see it speeds up a little bit. But anyway, you can see how this is pulling it through the air. Let's speed the motor up a bit. Yeah, there's kind of a constant fight between the torque and the angle speed that we wanted to achieve. I'll try doing 10 times the torque. Even that, like the 10 times the torque doesn't, you see it's still not going. Or are we just way underpowered? Like I'm starting to type in crazy numbers here and it's still not speeding up. So I'm starting to think that this isn't about like the torque per se, but more of like this lift power is like we're overdoing it. As soon as I lower that down a bit, you see it's able to spin more. So I think there's just like lift is like lift is creating a type of drag which slows it down. So anyway, you can see this is doing a pretty good job of pulling it forward. If we looked at it perfectly from the side, I think we will see it's going to be losing height slowly. See how it's slowly drifting down. Although now it started drifting down, and now the propeller is starting to aim it back up again. So we might get a sort of oscillation going, or if there's enough power, it will just keep dragging it. But the things in theory could start getting interesting, and hopefully in a very simple way. If I start twisting these things around, let's see, now, yeah, just by turning the tail, do you see how the entire thing is now tilting upward? So I've essentially said like the air is catching under that tail just a little bit more. So now it wants to pull the back end up, which in theory could stop it from going. So if we were trying to build some sort of like controllable rig, or even you wanted to keyframe this, you could start aiming this up and down, and that will actually change the direction that the plane is going. And if you want to, again, get fancier still, we could go onto the wing, and I'll make a child here. without even going overboard, let's put a flap there and a flap on the other side. So that should essentially not change anything because those are still kind of flat and even. But if I take one flap and tilt it upward, and it's not pivoting from the right spot, but even just by tilting it upward, I imagine, yeah, look at that. Instantly, it's going to begin banking. So, you know, all of this makes sense. I think all of it's behaving kind of the way you'd expect it to. It just goes to, at a certain point, you need to balance this out. Like if the plane was dipping too much, we'd want to take both of those and maybe tilt them down a little bit, which makes the overall wing thicker, which I think should be providing more lift. And you have to find like that right balance place. And anyway, at the end of the day, all I'm saying is, like, yes, you can go and build this rig, make it as elaborate as you want, build all the controls out, make it look pretty, and it is dynamically running. Like, yes, it is doing that. And I have done things where, like, you use espresso, and then you could potentially make it so that it's self-balancing. We are not going to spend the time to do that. But, you know, it would be, you know, there's no reason to be like, oh, if the nose is lower than the tail, then slowly start tilting the tail up. Like, you could build that type of thing. But then you'd have to do all sorts of, like, it's really easy to say that would work, but it even goes to like in real life when you're building like a quadcopter or something, when you're trying to balance out like your PIDs, the speed in which it like adjusts and calculates and changes and like how much it overcompensates and whatnot, like all those become variables because you can start getting like oscillations in it. It can get really crazy really quickly. Let's see, other things, potential. I don't know if it would work. Potentially we could make the rotor, the blades here heavier. And that might make it, if we give it a custom density, let's say 10 times, it might make it faster. It might make it spin slower. Yeah, well, they're just heavier now, so it didn't really seem to change anything, except for them being heavier. And then, I mean, ultimately it goes to, now we've got this propeller. And if we lower that propeller down, which really shouldn't break anything, I don't think. The balance might be a little bit... Okay. Well, let's make sure we grab the connectors for those and also move them down. And that shouldn't break anything. I don't think it's going to change too much. It's you know, tilting it up a little bit. That's fine. But now we could presumably apply some sort of collider here and put the rubber band on it so that it would be twisting the rubber band. But you'd have to pre-twist it one way so that you could then make it go the other way. And you'll see in the reference that this is all offset a little bit more towards the bottom. But I don't know. I don't feel super inclined to merge these rigs. Start getting the next question together. We will be moving on to the next question soon. But essentially what I want to have happen is I want this to spin and mimic what the rotor is doing. But I don't want it actually to be part of the dynamic system. And honestly, that's probably pretty straightforward. If we add a rigging constraint tag, and I say, hey, I want you to match the transform, not of the position, but yes, of the rotor's rotation. Whoa. Oh, I guess it's not part of the dynamic system, so it's just not moving with it. That's probably fine. I'm going to make it a child of the body of the plane, and then give it its own dynamics tag, simulation, no, bullet, rigid body, but then I'm going to turn off dynamics. So essentially it's like, oh, I'm underneath the dynamic object. I should go where it goes, but I myself am not dynamic. So anyway, the hope here is like, yeah, now it does pop kind of oddly. It could be that the dynamics calculate at a very particular time. So this, you see, it's already falling a frame behind. Now you can do that if we go into the constraint tag and I say, hey, I want you to calculate after the dynamics, then that might not, no, even that one's still going. So I think it actually happens at generators, and dynamics happens at frame 4 or at refresh 400. So if we say 401, then if I go one frame forward, then you see it is in sync now. But you gotta keep in mind that now all of our constraint tags are happening one frame later. So that can be dangerous. But anyway, now we do indeed have something that's twisting. So, you know, we could wrap the rubber band around that And it's, you know, this is in no way part of that dynamic system. So, you know, so it would work. But like I said, you have to pre-twist it and everything. So essentially, you know, if you're inclined to, I've shown you the 2 different steps. You could combine those 2 rigs, and you know the rubber band would be spinning, but only for as long as you do it backwards to pre-wind it up. Let's see. Demi was asking about a physics simulation experiment. Does the new engine include centrifugal force? If you link a rope with a ball on the rotating arm, will the ball lift? That's a fine question. I think it would fall behind a decent amount. Let me save this as bullet helicopter, and now it will be the bullet plane. Let's go back to the bullet helicopter setup and make the body of the helicopter a not dynamic object, which means that should spin, but it won't move anywhere. And now we can try applying a rope. Now this is spinning, and we should be able to apply just a rope to it. So we will be combining the 2 systems, but keep in mind they're not interacting in any kind of dynamic way. One is just reacting to what the other one did. So in the simplest form, let's create a helix. You know what's funny is we can actually leave that twisted. That'd be kind of funny. Let's do that and move this here. I'm going to turn on snapping. I haven't done snapping in a while. Shift S should turn on snapping. Boop, and there. You can see I perfectly snapped to that corner. And the helix has no subdivisions. It's exactly 100 points. And the ball on the end is actually a little bit dangerous. I'm just going to see what happens if it's straight up rope. So we'll move this after everything else. I don't know which one calculates first because I haven't tried to make these systems interact with each other. Simulation rope. Control D. Turn off CPU just in case. And currently they should just be ignoring each other. One's just going to fall away. Now let's link it. I will say simulation connector, or no, we can't do a connector because I only see things in the system. So we actually have to do a rope belt. Where did it go? Simulation rope belt. That's weird. Object, the object will be the rotor, but I think we have to make the rotor editable because we have to connect to a certain point. I think that's fine. We can just make that editable. So let's link there. And oh, maybe this has to be editable because we have to tell what point it is. I don't know if the rotor had to be editable. Maybe, maybe not. Select that point. And I would like that to be set. And now it's set to the rotor. So potentially dangerous. So let's give it a save. A, B, C, D. Oh, I did 2 Ds. E, F. Let us, I have no idea how to spell centrifugal, so I'm going to copy it from the chat. Centrifugal force. Test. Okay, I set the settings, I think all correctly, so let's do 1 frame. Okay, so good sign. You can see 1 frame went forward, that spun, and this rope is suddenly getting yanked forward. But like I said, it's everything else is being ignored. So that's just kind of a... It's as if I keyframed it for all purposes. So just hitting go right out of the gate. You can see it's spinning around pretty well. You know what? Like the way it's currently spinning, I don't feel like is necessarily wrong. Keep in mind they're not colliding with anything in it either. So a couple things. Let's make it very bendy. So I'm going to go up to like 111. That just means it's free to bend however it likes. Okay? We don't want any stretchiness. We don't need any friction. Even the radius is fine. But do you see how it's spinning? I feel like that's not wrong. Like if I take a heavy string and I start spinning it, it will do kind of this looping motion as it is. Like, it's not going to get whipped out. Like, and that, as the question said, it was like, can we attach a ball to an end? Let's play around a little bit here. I'm going to slow it down a bit. Let's have it be nowhere near as fast. Possibly we'll start speeding it up. So that's slower. And if depending on the frequency, yeah, you see now it's not spinning around like multiple times. It's only got that one extra curve inside. If we spin even slower, let's see, let it fall. So if we're at the proper speed, I feel like even this rope would whip out pretty well. Or is it or does it just trail behind? No, it should whip out further. If we view this from the top, let's see. Yeah, see, it's not just trailing. If it was trailing, it would be in this radius. You can see it's actually whipping itself out decently far. Now, can it catch up? I don't know. And is it catching up, or is it found some sort of stability? I don't know the question. I don't know the answer to that either. I guess we can try putting a ball on the end. I don't think it's good, dynamically speaking. I don't think it's going to work as well. And it doesn't need to be much. We'll make a small ball. Put it right there. Go to the top view and put it right there. As long as we get it correct on 2 dimensions, it should be fine. Yep, and that seems to have worked just fine. This needs to be a cloth to be able to see the same system. And simulation connector, it is currently looking to connect with other objects. Give me a live update. Draw, and as soon as I go up to about 3, you see suddenly this tiny little yellow connection was made, so it should be connected. Okay, sphere, I'm going to make it very low poly, so it's going to deform less. We'll say 0 bendiness. I'll balloon it out with its current pressure, so it's trying to maintain its shape. It's going to maintain its shape better if I put that to double, and I think that's all we can do. And then we can change the mass, which may be important. Save again. Should be fine. It's spinning pretty slow. Yoink. Okay, so that's now down on the bottom. So based on the weight, you can see that seems to have found a natural equilibrium in that center point. And honestly, I don't know what the speed would have to be to actually see this whip out, because I feel like it is mostly speed driven. So let's try going twice as fast. Try going twice as fast. Start over. Yeah, it's still, the center point still seems to be its favorite spot. Times 2. Because that's the average of them. That is super interesting. Again, I don't want to say that that's wrong. There could be a ratio. I don't know. I'm trying to think if I have anything in my room that I could kind of show this effect, but this is a real effect. I can pull out the magnet. Could pull out the magnet chain, but that wouldn't work. But I wonder if there's something to do with like the ratio of like the arm to the shape, or maybe the shape needs to be out further initially. I don't know. I don't have a good instinct for it. I mean, I think the faster we spin, the more it's going to want to stay in the center. The slower it goes, at least we have to ease up into the speed. So yeah, let's just experiment here. I think we might need a few more frames at the beginning. Its speed will be, it doesn't even matter the speed, so we'll just say it's going to start out at 25 or 15. That's fine. And then take up about half the timeline, and we'll go up to, I don't know, 5,000. So we're going to slowly, hopefully slowly accelerate up. So let's view this from the top. No, it's wanting to hang out in the center. As it speeds up, it is counter spinning the opposite direction. Still going faster, but now you can see additional curls are getting introduced into it. You see we're getting more of a spiral, which, like I said, I don't think that's necessarily wrong. would happen if we suddenly... I guess it's about to suddenly... No, this is the motor speed, so it's not going to suddenly stop. I'm going to try messing with the masses. So let's make that way heavier. Interesting. Let's make it way lighter. Keep in mind, there is still gravity. See, as it catches up to it, that's where I think the problem happens. Because like when you're spinning something, you're adding this very natural momentum to it. Because if you did it wrong, you wouldn't get the correct movement. That's interesting. It suddenly did catch up to it, and now it's all out of control. Although it does seem to be finding a pretty quick natural equilibrium. Yeah, I don't know. I'm not sure of what if it's wrong, because I don't. My instinct is not that this is wrong. But the different speeds could be relevant. The radius of this arm, I feel like, could be a fairly major variable. The length of the rope could be a variable. Like if this rope was way shorter, if it even goes to, yeah, if the rope was less than half the length of the arm, it couldn't get to this natural state in the middle, I don't think. Oops. Hey, stop it. I'm just going to delete out a bunch of these points. The sphere is probably not going to be selected, or it's not going to be connected anymore. Apparently none of it's connected. Helix point. Oh. Set, please. Still not that short, but yeah, look at this. With a shorter rope, I don't think it's able to get that same resonance, and you can see it's starting to spin. Ooh, interesting. It hasn't found an equilibrium yet, but do you see how we just got very different properties by changing one variable? So I feel like there's more at play here than I have a full instinct for. It starts falling behind as the spin keeps going, and then the spin gets ahead of it. But anyway, it's a very interesting question. I don't have a good answer, but let's move on to another question. I put, well, Zach, I put a lot of bendiness in the rope, so it was kind of as free to move as I could possibly make it. Making it less bendy would want to keep it in its original shape, but then we're not seeing the centrifugal force as much. Pete was asking about the airplane. Do the aerofoil sections make a difference to the lift? I guess saying off the top of my head, I'm not sure what a aerofoil is. Is that the if what you mean is like the natural shape of the wing, it's not doing like wind simulation. I think it's more of just assuming, like, imagine, I mean, air, you can think of air like a liquid in a lot of ways. Like if something's a liquid or a gas, it's kind of a similar thing. This is more of just thinking of it of like if all of space is static, if something is at an angle, if something's at an angle and pushing forward, you can imagine it the same as like a wind blowing into it. And if the wind is blowing into it, the wind would be bouncing off that direction, which means it's pushing it the other way. So I think it's a much simpler form of that. So I don't think that like properly designing the shape of a wing is going to do anything except for, you know, the overall angles would kind of be a variable. That's why I was able to just do completely flat wings and tilt them, because, you know, that's the way the system's actually running. Iagar, I'm not entirely sure of the pronunciation. Was asking if it was a continuation of... Oh, yeah, I see. You linked to a very similar thing where we did that whipping rope idea. The CrossFit type thing. It's not exactly a continuation of that, but, you know, again, we were kind of testing the limitations of the dynamic system. Just like there's a very valid question to ask about the shape of the wing, and you can see here is actually a good example. Like different shapes of wings create like different amounts of lift and drag, but the simulation system, the bullet system, didn't take all of this into account. It just cared about the angle of the poly, essentially surface area versus angle. I don't know if more sub-steps would have been changing much, but, you know, I'll try. A couple people are throwing out some suggestions. I don't have much more of a good instinct on here, so I'll try. Let's go, I don't know, let's go overboard. Let's do 3 times as many sub-steps. I don't think that's going to look very different here. Looks a little more jittery. I was saying it wouldn't change much, but that does feel like it's a little bit more on the outside, doesn't it? What are these zigzags? That's super weird, isn't it? And it's, yeah, I don't even know what to make of those zigzags. And somebody's saying the ball on the end would potentially have to be heavier. I don't know. Let me see if I can undo and get back to, yeah. Hopefully right here, everything's back. So our sub-steps, we'll try putting those back up to 60. Let's just see if that's any different. And then we'll try making the ball heavier instead of lighter. I did try making it heavier at one point, but this is just with extra sub-steps. The ball is significantly dragging the entire thing behind. The arm doesn't seem to be able to get out, and it falls behind. And yeah, we get in that spinning pattern. So now, okay. This is now 10 times heavier than it looks like it would be. So it's going to super yank it down. It's lagging behind more than anything. So now the string looks like it's having to like stretch to compensate for the weight of the ball, and now it's almost wanting to go dead center. So making the ball heavier seems to have made everything worse. I'll make it 10 times heavier again just to see. Yeah, making it heavier seems to not help. I don't know if this is I don't know if this will work, and it might take a second, and I gotta be careful about getting the magnets too close to things, but hang on. Okay, so let me switch the camera. Okay. So I've got this, and it's a series of little magnetic balls. So you can see I can pull it out as a spiral. I'm going to try and take a smaller section here. Let me do it here. Yeah. So let's see if I can do it up on the screen. You'll see, I'm going to talk loud because I'm away from the mic. You can see that, I got to do it lower. If I spin it, do you see how it's in the center? Like this midpoint is spinning back around. It's not whipping around the outside. And I think that's the effect that we're largely seeing. So if you think about, yep, everything's getting stuck on itself. So if you wanted something to, yeah, see, even, you know, if I take my own hand and then start spinning this around as if I want to spin, I am naturally matching its frequency so that I can feel it. I can feel it in the proper spot. So there's a lot of nuance to like actually getting that in the correct area. That's what I think is happening. I don't know for sure. And Alex is saying, yeah, the magnet balls are a perfect way to show the spline set to uniform, which is actually true. It's a series of spherical, like little spherical connections. So it's actually probably as close as we can get. Tim is saying that we needed to have a heavier rope. I mean, turning off the sphere, we don't need to make the rope heavier by connecting more balls to it. We can just say, oh, the rope is heavier. So I can make it like 10 times heavier on the rope. So now it is just heavier. And then I don't see much of a reason of like changing the ratio from the ball to the rope. Like if making the rope heavier is the same as making the ball lighter. But, you know, increasing the subframes did seem to be letting this go out more, but I don't know why. And I don't know why we're getting this wiggly pattern happening in it. That could be some sort of like almost frequency pattern emerging where different steps per frame, different substeps could be, I don't know. I don't know the way the springs propagate down through the chain. So if we jump this up to 100... There's also, honestly, there's this damping as well. So that's constantly draining energy out from the entire calculation. So that could have a variable. And you see as we increase it, we're getting these like wobbly frequencies traveling through. And, you know, it doesn't, as we add more substeps, and I've talked about this before in regards to soft bodies, that adding extra substeps does not necessarily make everything look smoother. You can see here in this simulation that somehow this is adding like these like waves traveling through it, and I don't have a good instinct for why. Anyway, I would love to get to a completely different and unrelated question. Let's see. Scrolling back through the chats. Nope, I am not continuing on this rope thing. I'm done with ropes for now. Bazimga is asking if anybody knows anything about Merc. I do not know one way or the other. Trey, thanks for hanging out. Let's see. Are there any other questions? If nobody has any specific questions right now, then we will wrap the stream up early. I'm trying to think of anything else I've had to demo or play with. I have done a couple of rigs for some clients lately, but I can't really show those off. But they were fun rigs. Monty's got a link. What you got here? Ooh, it looks really cool. Let me pull this out. So this is from Agent's White Dog, but it's specifically saying by Globibin? So if we click over the Globibin, yeah, okay, they have it. So as a general rule, if check to see who made it, because, you know, I always want to go back to the original source. Yeah, that's super crazy. This does have a nice kind of simultaneously satisfying, but also simultaneously a little bit tryptophobic almost. So yeah, that's cool. Let's see if we can do something along these lines. There's a lot of things that are very specific to that I want to be careful not to just be, you know, perfectly replicating. But the base idea would have to be similar, essentially just the basic banana peel idea. And pulling away from a banana peel type shape. So if we have a cylinder, and we'll give ourselves a few extra rotational segments, why not? We don't need any height ones for the one that just remains static. One of my main questions is if we take a cylinder, and I'm gonna have to cut this divided by 4. I guess one thing we could do is divide it by a different number, because that one has 4, and then we could do something like 5. So does that divide by 5? Probably not. So let's do 5 times 9, 45. Okay, I just want to make sure those are even. So I should have 2 cylinders, and they should, well, they're not matching now because the one that's set to 9, I should go to slice and only look at a fifth of it. So we go to 360 divided by 5, 72. So now that should be perfectly 1/5 of our rotation. Let me increase its radius just a little bit, and we'll change the color on both of them. Why not? Maybe a nice yellow. Hint of green. Okay, so you can see we've got these 2 different shapes, all good. Now, this one is the one that needs height subdivisions. It's going to need quite a few. I say 1,000 for now. Oh, that is way too many. Good to know. 200, there we go. Very nice number. 300 is probably going to look even better. Okay, so is this potentially as simple as, and you know what, I'm going to make it easier on myself. If we go to slice, currently it's at 72. I'm going to say minus 72 divided by 2, which is 36, and 36. So you can see I just split the difference. The point being is now it's in the center point. So the most basic possible thing would be creating a bend. And I guess I'll drop it inside and say fit to parent. Oh, was that the right cylinder? Well, that's interesting. It's viewing the original object. Why is it, it's perfectly matching the overall cylinder instead of just the modified geometry? That's very strange. I think it is. Let's put it into a connect, and I'll fit it to the connect. Doop. Yep, when in doubt, use a connect. Okay, so that bend is now perfectly matching that, but the entire height, I don't want the entire height, so I'll change that to 200 of height. Cool, so now we get that. And we give it some bend. So give it some strength, and you see an excellent job of curling away. And you know, the simple version is I just take this and start pushing it down, and it's going to perfectly peel away. As long as it's getting out of frame, then that's fine. You have options where we could take this and say, make it, you know, I'm gonna make it more than twice as long. And now it's got, you know, now it's twice as long, which means the radius is larger, which means as it curves away, it's got kind of more control as it goes further away. If you do a very small curve, then, if you do a very small curve, then it's going to be very sharply curving away. If it's very long, then it could slowly pull away. Having said that, we can also add a little bit of extra rotation. Is that going to work? Oh, within box. I mean, I don't say unlimited. Maybe we want to say unlimited. I don't know. I thought if we put a little bit of rotation in there, it would keep on spiraling, but it would have to be unlimited to do that. And as we keep going, yeah, then it'll keep on curling, and in theory, it would curve all the way back around again. And then we'd have to put a limiter so it wouldn't go down. But essentially, like, especially if we're just matching the original, all we have to do is say limited, and this is already working. So if we move up here and keyframe, all we have to do is keyframe on Y. Let's go 500 frames. We should probably go Control D, project, no, animation, linear. So we are going to get linear keyframes. Kill that off, re-record, and I suppose just go all the way to the end. It's going to be maybe too slow, but let's go all the way through. You know, I guess even till right about there. It's fine. Keyframe. So now hide the bend. Zoom up, and now we can hit play. And now you can see that that's going to very, very nicely, very cleanly peel away. And you know, however long we make it, that could essentially be lasting forever. So very clean, simple rig right there. Throw that into a cloner and set that to radial, radius of 0, and it's already set to a count of 5, interestingly. So that should be 5 different ones. And let's go back to our green blue color and hit play, and now we get 5 different ones all peeling away, perfectly matching. And you know, we can just link up on the camera and have it travel through. Looks really nice. Now as far as the actual pattern on it, it would be, you know, just modifying the original geometry. So turn off the original. We can see this quite well. Trying to think of what I want to do. Why don't we make it, we can make this via some geometry capsules, geometry modifier capsules. I do want those to be little more square. What would the math be on this? Oh, I don't know. A bunch of curves happen. I'm just going to eyeball it. But yeah, a little more square. If we go into our geometry node, so here is the new neutron scene node stuff, but we can use it as geometry modifiers. A lot of people don't know that this is a thing yet. We're going to do some fancy stuff with selections. And these are definitely some things we couldn't do before. So let me just show you as a for instance. If we, I don't want a modulo. Maybe I do want a modulo. Is it a modulo? I'm going to throw in a modulo. Yeah, maybe it is here. Where you see every 3 count 1. Now, it's not going to do much for us right now, but if we now do a modifier and say something like delete, then now you can see, you can actually see the result. And the result is it selected the first polygon, skipped 2, and selected the third. So I am now able to select a very specific pattern here. So now I could say every 4th select, and the pattern's not super intuitive visually here. Maybe it's traveling downward. Yeah, I think it is traveling. So it's actually going like 0, 1, 2, 3, or I guess it's probably 1, 2, 3, 4, 5, delete. 1, 2, 3, and it's doing that. And because it's just a, it's able to select those. So we are traveling downward. And if I do the correct amount, we can probably get a cool looking pattern like that. So that could be cool. And we are deleting out that polygon, which works. We could, in theory, delete these from the outer part, so we only get the inside. I'm a little fuzzy on here, and we've had a slight refresh issue. I think one time we tried to do this. Let me save this. I want to do a geometry selection, and I want to set the selection. How do I do that? I'm going to say I want to store the current selection. What do I want to store it as? I want to name it, I don't know, I'll just call it, no, mod might mean something, so let's not call it mod. I'll just say pattern. Pattern 1. Okay, so that should, in theory, be pattern 1. So now, instead, I'm going to select, after that happens, I'm going to say, okay, select, and I'm going to say all. I've selected everything, okay? And then I want to, actually, can we say all? I want to select all minus quotes pattern. And if I move this delete down to the bottom, yeah, okay. So what happened is I selected everything and I said, okay, but now get rid of what was in the pattern. Excellent. I mean, that's cool. So I've now inverted it. We could have inverted it in other ways, but what I actually want to do is this outside. So we've selected all, and I would like to shrink my selection. There should be a shrink selection. Shrink selection, there it is. Okay, so I selected everything. I've shrunk the selection to the outside. And, oh, and that's still got the pattern, so that makes sense. So let's just say select all. Okay, we're selecting all, and we've selected the outside. You see, that's what's getting deleted. Okay, now I'd like to invert, and there should be an invert. So here's, let's invert that selection. And you see that the outside is what's getting deleted. So then I will store that selection. So I'll duplicate the store selection and say I want to save this as outside. So now that is the outside selection. So now if I make a new select, I could say I would like to take, in quotes, pattern 1, and then get rid of outside. And then that gets deleted, or in theory. Oh, I should call it, type it incorrectly. There we go. Okay, that was a couple of extra steps, but now I was able to get rid of that outer one. So no matter what pattern we feed in, this outer bit is going to be protected. So now we can always go back to this modulo and say actually every 8th or every 9th or every 10th. And so I can get all sorts of cool, crazy patterns in here. If we get the proper one, you can see that every 16th with this particular configuration is kind of a nice looking random-ish pattern. It repeats. So cool, we were able to do all that parametrically. And then, you know, still we're kind of free to do whatever we like. In this case, why don't we add in a solidify? And after the delete, I will add a solidify. So nothing is selected, which means this gets applied everywhere. It's pushing out, let's say 5. And now you can see there's been thickness added to it. And we can now go to geometry modifier. And I mean, we can do a lot of this through things, but as long as we're using capsules already, I'll say I would also now like to smooth the geometry. So that should just be like a subdivision surface. So I drop that in, you see the entire thing's gotten smoothed out. It's a bit brute force right now. It's, oh, actually, no, this is smoothing geometry. I don't want smooth geometry. I want probably just subdivide. Subdivide the geometry. And I can say I want that to be a smoothing type subdivision. And I can see everything's gotten nice and rounded. So, you know, perfectly rounded are there. We can, around there, I can increase this just like a subdivision surface. And I can see that these have become nice and clean and rounded. Anyway, the point being is you can see how this is working. It's working actually quite nicely. I'm trying to think if there's any fancier thing I could do there. But yeah, now that all that's there, it's all happening before this bend. So even though I expect it to be running a bit slower, I can turn this back on again. You can see our new pattern, kind of cactusy looking. If I hit play, all of those capsules are going to be running a little bit slower. Like, it's significantly slower, but I can just scroll through here. And you can see that all that geometry is now entirely parametric and still getting bent away the exact same way. So, pretty cool. I'm going to shrink that down a bit. I want to see that sharper. Yeah. Yep. Put the original cylinder in there. And again, like it's all here. It's all live. It's all parametric. So, let's say every 3rd. And now you can see completely different pattern. Every 4th. Oh, yeah, look at that one. Every 4th, very nice. Kind of a... This solidify and subdivide are going to be like doing a majority of the slowdown for us. So if we turn those off, it's going to be running okay. And then the, oh yeah, and bend, always turn on keep length so it doesn't stretch it. And then, I mean, the in the animation, it was presumably built in a way that you could see a perfect looping pattern. I'm not super, well, here, I mean, it goes to, if you want to get a perfect looping pattern, it's all just about finding that loop point. So let's find where this kind of starts looking uniform-ish. And how do I want to do this? We've got this bend. Yeah, that's fine. I will make the bend, create a null. I would like this null to constrain transform-wise to the position and rotation of the bend. So now that null is going to go wherever the bend is. But that means I can create a camera and put that under the null. And now we're going to be moving with it. So I can set this up however we like. If we want to match what the other one looked like, we can always just like rotate our camera. But I'm going to leave this a little bit more vertical. So now... we can start wherever it looks like we've kind of, you know, even right here, it's like, okay, well, we've kind of seen the pattern, or we can move it up to a different position wherever it looks nice. And right here, it's like, okay, cool. Like this looks the way it looks. Cool. So now if we say that our actual timeline is going to start at, let's say 107, now we just keep scrolling forward until we get to a spot where it looks identical. And honestly, it looks identical almost like a couple frames later. I'm trying to think of a good way. If I make a connect object and select all of our rig, bake that down, copy it, undo, 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 undo. Okay, and paste. Now I've got a chunk of geometry that's static. If I make that a child of the camera, it's going to move with us. And now I can just keep going frame by frame forward until these match up again. And like right there, looks like a pretty much perfect match. So if we go one frame before that, so that's only up to 115. So this is a very short looping animation. I can delete that connect. And if I play right now, we're going to get what looks like an endless animation just by looking at this a few frames repeating, because all you need is that pattern to happen again. So when it comes to looping something, all you need is it to be in one state and then get back to that identical state again. And it's usually a good idea if you can get into it. If you can get to it with the motion having not changed. So if something was like bouncing downward and then bouncing upward, you don't want to match the downward motion to the upward motion. But anyway, you can see how easy it was to set this up to loop. And now subdivide, loop, and we get these nice curves. And then, you know, and we could put this exact same pattern or the inverse of the pattern onto the shape. Even with the way you've got this rig built, I mean, since we've gone this far, why don't we even try and plug the holes? Because for the most part, all that's going to be is duplicating this rig, so the cloner. I don't want the bend to apply to this copy, so you can see now it's here. And I can see we've got this pattern, like the pattern's good, we need the opposite. And here's where building the stuff parametrically is great, is if I go back to my geometry selection, in this particular one, we create a very advanced selection right here. So if I say, well, after that advanced selection, I actually want the opposite. So under geometry selection, I'll say invert the selection after that. And now, with any luck, the exact opposite thing has now happened. And now we're just left with the dimples, which are the perfect inverse of what we had. The solidify could be pushed out further. So let's push that like 15. Oh, apparently it's pushing inward. So let's do negative 15. And subdivide comes after. So it actually looks like this. So I'm thinking, what if we copy it's always, I have it in my head pretty well, but just so we can see it step by step, I'm going to turn off the solidify, and you can see we've just got a bunch of rectangles. If I move a subdivide above that and then subdivide at this step, you can see that those are now going to look very round. And now when I solidify those, we are actually extruding out from a round thing, and now we get these pillar-looking shapes. And then if that gets subdivided, then we should get a lot more of kind of that canister shape, or I guess it's a little square-ish. Let's only subdivide one time. It's still a little more square than I was expecting. Let me see. NB. Yeah, it's perfectly round. When we solidify, yeah, they push out fine. I would have thought the subdivide would look a little bit better. I guess it's not wrong. But we can, anyway, that's a very specific detail. Like just from our original rounding, I could subdivide this one extra, which will make that look more round here. And then we get the final caps that way. And then that was a solidify. But instead of pushing out via a solidify, what if we instead grabbed a geometry modifier, which is an extrude? Let's do a straight up extrude, which actually will create less geometry for us and make a really sharp beginning. Now you see all of those getting pushed out. Right now, they're each individually pushed out. You can see if I show you with a little offset variation, you see how each of them is separate? We don't want that. So we can say, actually, use islands. And now all those should get merged. And now if we use offset variation, then they'll all become a different length, which could be a cool detail here. Push out not so far, but now they're all randomized a bit. And that's an extrude pushing out based on this current selection. But even there, we could do an inset, or let's do a bevel. Bevel, 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 bevel. Chamfer. It's not a bevel, it's a chamfer. This one's obviously taking a while to calculate. I think it should, oh my goodness. It's set to points by default. Actually, why is there no polygon option? Why is there no polygon option there, chamfer? Well, apparently there's something here called polygon bevel. Why is there? Did they separate these out as two separate tools? Why would they do that? I'm not saying there's not a reason. I just can't think of a reason. So that's exploding, but in theory you should be able to click use islands. Still super crazy. That's extruding. I mean, the offset's huge. Let's do it small. What is it doing? Oh, interesting. Proportional, use islands, max angle 89. It could be that the nothing was selected, so everything's selected. So we might want to do a select all. So right before we start doing all this crazy stuff, I'll put a select here and then say all. Select all and see if it behaves. There we go. Now it's behaving itself. Yeah, so polygon bevel, inset 20%. I don't want it to be proportional. I want it to be absolute. And 100 is obviously ridiculous. Let's do 5. Even 5 was ridiculous. Let's do 2. 1. Yeah, anyway, my point being is that you see I was very manually making a shape. Are these kind of out in the air? They're floating a bit, not too much, but they, I was going to say is why don't they feel like they're matching the holes very well up here? Because they're matching down here. They are matching down here. I thought that I told the bend you have to keep length. And I mean, that helps a little bit. Why? Why? I have, well, one small thought. Let me turn off these cloners because it's going to speed everything up a bit. Is it because the bend is so far in? Oh yeah, we're keep in mind we're a child of the bend. Oh, okay, actually this is, oh, okay, it's stretching a size of 0, please. Yes, no? That didn't do anything. No, even that doesn't make too much sense to me. Well, you'll see that as I move this in and out, you see how it's stretching it? Like clearly that's having a big effect there. So if I move it in the correct amount, but like I say, I thought setting that to 0 would fix it, but then again, we are working off of this curved shape, so maybe that's causing the problem. Do you know something else I thought of, I guess in a good way? It doesn't matter where we move our camera. I think the loop will still work because we're still moving the same amount. Although, keep in mind that we now made this random pattern. That random pattern is going to break it. So you know what? I'm going to stop the random pattern, which is simple. I can just go to extrude, offset variation 0. So they should be back to being identical. I don't know for sure because of the offset pattern, but if I hit play, yeah, see, it doesn't matter where we move our camera. It's all about, it's going to look the same no matter where I go. So if I move here, it's going to look like it loops. If I go here, it's going to look like it loops. Like no matter where we go, it's going to look like it's looping. So, you know, that's pretty cool. Let's turn back on these. Those actually could be set to multi-instance. That might help a little. Yeah, reasonable playback now. I guess we don't want to see those corners where they escape. So let's just zoom up enough so that those are not happening. Yeah, so yeah, it doesn't matter where we're looking. We're going to get our looping pattern. These little insets. Yeah, I mean, so many options. Is there anything else anybody'd like to see me change or tweak on this rig? I mean, look, this is entirely parametric, which is pretty cool. Currently, these are sticking out from the side a little bit. We could always offset those inside. I think there's probably a transform of some sort. Transform element. But that might not be the geometry, so I'm not sure if this is what I'd want to do. Before we subdivide, after we've deleted, I want to transform the element. Yeah, that's based on the, oh no, it's type points. Maybe it's the individual ones. I don't know. So if I say polygons, push back on X, Y, I mean, I'm assuming Z. So let me say -5 should be enough to eyeball. Okay, well, it moved. Is this moving in absolute way or a relative way? It does say pivot from the bounding box. So it's making me think that's going to be absolute. Actually, I almost guarantee that this is absolute. Yeah, that's all moving uniformly. This is the one we need, but I don't think it's going to work. I don't think that worked. No, these are moving in an absolute way. Yeah. So it's not, that's not about the polygons. We could do it in other ways. Mostly by extruding and inverting. I don't want to go and do all of them. There'd be a bunch of, not a bunch of steps, but there'd be steps to make that actually work. But it's cool that once you make the rig, you know, it just loops and it doesn't matter where we put the camera. So cooler than I thought it was going to be. Some of those seem to be passing through. Oh, I guess maybe that makes sense. Well, I guess the way the curve is happening, but yeah, some of these start looking like they're sneaking through. They are in the hole, but the way it's being forced to bend out, because essentially those are poking out like this, but the bend is wrapping up this way. I don't really think there's too much of a way beyond that. It just goes to I made our lives a lot more difficult by extruding these out extra far. So the original reference, like, it's keeping it subtle, so like here it doesn't look like they're bending through because it's nice and short. So keep in mind those types of details. Also, I guess the original animation was going backwards, so isn't there a play backwards button? They used to have it in the interface, but what is that called? Play forward. So if we search for play, there's got to be a play backwards. Boop. Aha, play backwards. There we go. Now we're more matching it. Let's see. Maybe the bend is rotated a bit. I mean, I don't think that in the original reference that there was any need for the bend to be rotated. I think it is just straight up like this. Like I said, we could spin the bend. Excuse me. We could spin the bend. So that it would like curl in on itself, but that's just not the setup that we have here. And then that would make it not loopable because it'd be changing every frame. Yep, reshucking the corn. And yeah, there's a lot of cool things about it because any change we make to one, like we can have it automatically happen to the other. If I grab these two modulos and we jump this up to like 17, like boom, instant, they perfectly match and we have a different pattern. We could say that every 17 we select 4 and now we're gonna get these long lines. That's kind of cool. Let's actually say every 17 we select 8. And let's say every 21 we select 8. And yeah, we're just getting these super crazy patterns, just typing in these random numbers. And we could do even more advanced things by like combining multiple versions of this. Little zigzags. You never quite know what you're going to get. These are just emergent patterns. We'd say like every 1 select 15, and now, well, apparently that's not quite enough because we're not seeing any deselected. That's interesting. Maybe the second number needs to be smaller than the first. I wouldn't have thought so, but it does work. Yeah, it's cool. I like it. Oh, that sucks, Eric. What's wrong with your browser? Is anybody else getting crashes on Twitch? Okay, we're almost exactly at the end here. Does anybody have any like not big project questions, but just like a tweak or anything else about this? Anything about these capsules? In any case, it was a fun one to sneak in there. Trying to think of anything else I would do here. Those subdivides are going to be really slowing us down. Not that, we'd really want to get rid of them, but if I turn that off, like there's going to be so fewer polygons. Yeah, at some point it would be. It just goes to capsules are such a big, broad thing. Like this was just happened to be a really good example of something, of some fun stuff we could do with capsules. it does look like I mess up the pattern if I don't have one that's kind of in frequency with our original. Even setting this up to loop was kind of fun. What was the original pattern? I don't remember. I've messed it up. Save this as next version. Zach is asking, you've seen me navigate the object manager very quickly, and I think with the keyboard only. Can you talk about shortcuts for renaming, moving items in the object browser? I don't think I do too much in the object browser. I think I'm just clicking quickly. The there's no, I don't think there's any good way of renaming, like, you know, renaming, I'm always just double clicking. And once you've renamed that, if you can hit down and cycle through and you're still in the renaming, so you could rename by stepping through. But yeah, just double clicking on any will put you in the rename. And I don't have any shortcuts for like navigating. You can always, you know, just use your keys and jump around, but I am not using the keyboard, I don't think. Wish I had a better answer for you, but. And then, well, and it goes to the shortcuts for placing things. I guess the one thing I have been doing more, although I did say that there's a bit of a bug, but if I create a cube, well, I mean, the standard would be the sweep idea. If I make a, let's say I make a circle, and then I want to put it inside a sweep. If you hold down Control as you create sweep, nope, I even did it wrong there. Is it Alt? Yeah, if I hold down Alt as I create it, it will automatically be a parent of the circle. And now that I have the sweep selected, if I hold down, I think Control, as I say create an end side, nope, I guess it's Shift. As I like, because I'm saying it out loud, I'm messing it up. If I hold down Shift, it'll create it as the first child of the currently selected object. So without having to like build this hierarchy, you're able to build it in. Control is actually kind of important. I know it's the one I've been selecting incorrectly, but you'll see if I select this object, and right now if I were to make a cloner, it's going to appear at the top. But if I hold down Control as I make the cloner, it's going to be a sibling of the currently selected object. So you can place the things very quickly using Shift and Control and Alt. Yeah, and of course there is the renaming tool, which can be pretty useful, like selecting all these cubes. I can never find it in the menu, so that might be a good one to search for, because it's not, I think I always search for renaming, and it's not going to find it because it's just called the name. And you can't search for the word name because it doesn't work either. You have to search for naming. So searching for it is very difficult, even when I'm typing it out, because it's, you would think you could type in the word name. You would think you could type in the word rename, but neither of those work. You have to do the renaming or just naming tool, and you get this. So here, you know, we could remove and replace suffixes and prefixes. So, you know, to start out with, you could just start by renaming all of these cube, and then go for the naming tool and prefix them all by, I don't know, me underscore, and then, yeah, how do you execute on that? That's load preset, hit add. See, yeah. Oh, apply. That didn't work though. See, I applied two objects. Maybe that's to replace something. I don't use this very often. Maybe we just do this. So I say replace, and there. Now, yeah, maybe this is for like find and replace, and then this is just for replacing. I wish the word find was up here then. And then suffix. And then there's all sorts of shortcuts for getting like a number. Add, no. Yeah, if you search for the naming tool, I bet that there is a bunch of, like, here's how you put numbers on the end. Yeah, so number n would put numbers. So we should be able to do a suffix of underscore number. And get rid of that. And now, yeah, underscore number. Underscore letter. Underscore capital letter. It looks like most of them. Pretty straightforward. Nice. Well, we're exactly on time. Naming tool is good. Yeah, and then I guess with my new resolution, the mouse is a little smaller on the screen than it traditionally used to be, so that might make it a little bit harder to see. As long, I mean, yeah, and the mouse does show up, but yeah, it's a tiny mouse, so maybe I'm just moving it quick. Demi, why don't you upload the live show to YouTube as soon as it ends, or at least the next day? Because I put it up on Patreon right away, and then it shows up for everybody else 2 weeks later. So if you're supporting on Patreon, Demi, then you would see the episodes pop up right away on the other channel. So it's like you have to be here live, and then you get the show live. And if you weren't here live, then you have to be on Patreon, or you have to wait 2 weeks. Oh man, Basil's asking about the muscle system. The muscle system, it does certain things. It does certain things okay. It's very specific. And I'm trying to think if I've ever, I mean, I have used it. I'm trying to think if I've ever used it and like felt satisfied after having used it. In fact, I think there's even a point where Maxon removed it because they're like, nobody uses this tool, so we're just going to take it out. And then some people complain. They're like, I use it. And they're like, okay, it's back. But yeah, just throwing that out there. But I do believe that will wrap it up. I guess as we're wrapping up here, remember if you have Amazon Prime, you can go follow on Twitch, and you can give me a subscription for free for you, and then it would be supporting Rocket Lasso. So that's a cool thing you can do. There should be a link in the description about how to do that. But besides that, I've got that neat little highlight tutorial thing, which will be going out Monday. And that should wrap up this week. I'll see everybody on next Wednesday for the next live stream. Yeah, that should do it. Thank you so much, everybody. I'll see you in exactly one. I'm trying to think of anything else. Probably something, but I think we're all good. See everybody in a week. Bye-bye.